All right, everyone, welcome to day 4 of Advent to Code 2023. 5 seconds here. Code is all ready to go, and let's get into it. The gondola takes you up. Strangely, though, the ground doesn't seem to be coming with you. You're not climbing a mountain as the circle of snow island recedes below you. The entire new landmass appears above you. The gondola carries you to the surface of New Island, which is the station. As you exit the gondola, the first thing you notice is that the air here is much warmer than it is in the snow island. It's quite humid. This is where the water source is. The next thing you notice is the elf sitting on the floor across the station in what seems to be a pile of colorful square cards. Well, hello, how may I be of service? You ask about the water source. I'm not sure. I just operate the gondola lift. That does sound like something we'd have, though. This is Island, alright? I bet the gardener would know. He's on a different island, though. The small kind surrounded by water, not the floating kind. We need to come up a better naming scheme. Tell you what, if you can help me with something quick, I will let you borrow my boat and you can go visit the gardener. Got all these scratch cards as a gift, but I can't figure out what I've won. The elf leads you over to a pile of color cards. There you discover a dozen scratch cards, all with their opaque coverings already scratched off. Picked one up. It looked like each of the card has 2 listed numbers separated by a vertical bar. The list of winning numbers and the list of numbers you have. The organize information to a table, your puzzle input. As far as the elf has been able to figure out, you have to figure out which numbers you have appear in the list of winning numbers. The first match makes a card worth 1 point, and each match after that doubles the point value of the card. So, okay, this has 5 winning numbers. The left is your okay. Yeah. Okay. And 8 numbers. Oh, it's 5 winning numbers. 8 numbers you have. Of the numbers you have, 4 of them are winning numbers. That means card 1 is worth 8 points. 1 for the first smash, then doubled 3 times. Okay. So we just need to know how many they're all worth. This seems pretty straightforward, I would actually imagine. This might be one of the easier, assuming nothing is, assuming I didn't do anything wrong here. Okay, so we're gonna go ahead and do inputs, and we're going to split on new lines here, as always, and we're gonna reduce each line. Actually, we're gonna return, yeah, some. Yeah. Okay. So I'm gonna return the sum. So for a given line, we're gonna do line split on this. And then we're gonna call numbers is gonna be equal to parts 1 and split on the bar. So now that we have the bar, so now we can do const your nums, or let's call them my nums, sure, doesn't matter. It's gonna equal to numbers 0 and split on spaces. I'm gonna trim this just because to make sure. And then winning nums. Actually, I'm gonna go ahead and also map this. Oh, it's just net num. Go ahead and do it for both of these. Okay, and then it seems like it's pretty pretty self-explanatory. What we're gonna just do is mynums filter and winning nums includes. No, I actually do that. Actually, yes, I'm going to do that because I don't want to pass wrong things. Yeah. And actually call just dot length, and then actually we can just do is equal to 2. Let's just call math dot pow of 2 to the winners minus 1. Actually, I should make sure that winners is greater than 0. If it is that, if I would do that, and we should just be able to do that. And this might just give us part 1. I'm just gonna send this, you know. We are just gonna straight up send that. That'd be really nice. I was hoping I could just get it right first try. Okay, let's do the test input. It's always a good spot to start. See what this gives us. See what we're expecting. We are expecting 13 points. That did not look like 13. Oh, you just wait. I got it right. Let's just make sure that this isn't somehow missing any. Oh wait, so no, I have not numbers. Whoa, hold on, I have not numbers in here. Oh. Oh. Let's throw a quick trim on these. So it seems I was right, I just had some bad numbers. Oh, that's gonna cause havoc. Wait, hold on. There are still some not numbers in there. $74, $59, $74. This 3. Yeah, there's. What? I trimmed those though. This is gonna kind of cheat. But I'm gonna replace all double spaces with single spaces. That should at least give me my answer. That works. I'll do it later. I just wanted to get the part correct. I'll probably try and fix that later. But for now, just as you're about to report your findings to the elf, you realize that the rules have actually been printed on the back of your card. There's no such thing as points. Instead, scratch cards only cause you to win more scratch cards equal to the number of winning numbers you have. Specifically, you win copies of the scratch cards below the winning card equal the number of matches. So if card 10 were to have 5 matching numbers, that would win 1 copy of each card. A copy of the same cards as the original. Once all of the originals and copies have been processed, you end up with 1 instance of card 1, 2 instances of card 2, 4. Okay, so what I need is I need a values. Okay, so what's actually going to happen is instead of this being a reduce, this will become a map. And this is going to become a map. And what that means is we're just going to have line there, and all it's going to turn is pow. And then what's going to happen is part 1, this is going to be the values. So part 1, I don't really, yeah, okay. Part 1 is just going to become values reduce sum and v, start at 0, and it's just going to become sum plus v. So I should see 23941. Yeah, sweet. I get rid of these real quick. Part 2 is going to be sort of the same thing, but I also need array, right? Oh, it's index and array, sorry. And what's going to happen is it's a little more complex than just this. So if, so we already have values. So for, it's actually going to be array slice. It needs the start, which is going to be index, and the end is going to be index plus v. Actually, we're going to only do this. If v is greater than 0. Oh, it's 0. We're going to slice these and then call reduce to sum up these. And this is going, because we're starting at this slice, +1. Actually, I can just do +1 there to include this one. Sum to v2. And this is just going to be sum plus v2. Oops. I think. I think. No. Okay, back to test real quick. 13 and 22. That is not right. So the example is going to get v, and v is going to map to array.slice. So we should see this number plus all of them. So 8. Original cartoon. Okay, it went 4 copies. Oh, how many scratch cards? Oh, never mind. I'm doing this wrong. It's just how many scratch cards. Length or 1. My bad. This should say 30. It says 16. Six. Wait, how does 8? Because I did that wrong. Okay, we're not gonna do power. We're gonna do. This isn't gonna be values. It's gonna be winners. And this can get moved. To here. Winners. V. Okay. So that should give us back our original for that. Let's get back part 1 again, right? Nope. Because I did that wrong. I forgot that. Part 1 was what? 23941. 13. It's the number of winners. Um, oh, wait. 13. Sorry, I'm doing not that. I'm doing this one, which is 13. 13's right. Good. So 15, okay, so now I am off. Format your numbers to win a copy of 2, 3, 4, and 5. Right. But I'm not recursively doing it. The problem is I'm not recursively doing these. So I have V is the winning numbers. So this one's 4. Within a length of winners dot length. So what I can do is I can do counts. Map. So I have the additional ones that are winning, right? And so then I have the V and I. I'm gonna use V, right? Yeah, okay. And this is index. And then when I'm mapping through this, I'm incrementing. I'm simply just checking if index is greater than this index and index is less than or equal to index plus additional. If that is true, we just return wins plus 1. Otherwise, we return wins. Can I just do as number? Wait, what does Phil want? No, Phil. Okay, that's redundant now. Alright, so I'm close. Why is win still unknown? Okay. Alright, so now we have our counts. So what happens here is we return no. Okay, wait, I don't return additional. We just return how but I'm not doubling, or I'm not exponentially increasing them. I'm missing a multiplication somewhere. I'm missing a multiplication somewhere. Because this wins all of these, but then now there's 2. I think it's... Actually, I'll do current because wins is wrong. I think it's actually going to be plus... plus counts of the current index. And then we're going to turn the counts of the current index. Go away. What? Zero function. What? Is this supposed to be 0? Okay. Supposed to use ones. What am I I'm messing something up here. So, thinking about this is like, so card 1 wins. So we have 1 card 1. So yeah, so it should be fill with 1. So this is right. So fill with 1. So this is how many we have. This counts as how many we have. So yeah, fill with 1. And then when we win, we want to increment 2, 3, 4, and 5. So additional is going to be plus 1. Actually, additional is actually just how much did we won, which is just V. So we just win V amount. And then you want to update current. Actually, I should just do this. I should just do counts slice from index plus 1 and then map all these old, and then just do current equals that's slicing it weird. Done. Zero to that. And that to the end. It's not counts. Sorry, it's not current. It's counts. And then we're also going to return that. We're just going to return, always return that. $194. What am I doing wrong here? It's like, I don't know why this is being so difficult. This isn't that bad. Oh, wait. Why am I doing it inside this map? Sorry, that map's probably old. That map was probably old, and that was probably why. Output index. And then log counts. So this one's 4, right? And then because it's not +1, it's plus this. 30, 30, 30. Hey, there we go. Wow, that was, oh my goodness. And we can put this back to input. I struggled a lot with that for some reason. I feel like that's the exact same answer we got the first time. Oh no, it's not. Okay, hey, there we go. Wow. Okay, let me go through and I don't know if there's anything to clean up to do, but let me go through and do it quick, and then we'll go over the solutions here. Okay, so no cleanup doesn't need to be no cleanup that was needed to be done today. Pretty straightforward. This problem, we are given these inputs of scratch off cards with the obviously the card number here, or the card name and number, and then the first set of numbers are the numbers on the scratch card, and then the right side numbers are the numbers that are winners. The first part is simply to ask how many cards are winners, I guess. Well, in a sense, it's asking how many numbers you have won doubled ish. But anyways, so it's pretty simple. We simply take our inputs. I do this. I meant to go back and do this. I'm gonna leave it because it works. But we go through each line. We split on the new line, so we can go through each line by line or each scratch card by scratch card. I split it off to remove this first half, and then I split it again to get our numbers and then the winning numbers, which is right here. So this is splitting it to get our numbers and the winning numbers. And so I go ahead and map them to be numbers, strings. And then we simply count how many there's a winning. And the way we do that is we simply just get all of the winning numbers and we say, does it include our number? Or sorry, we go through all of our numbers and we ask, is that number in the winning numbers? And they return how many of those are winners. That gives us the winners for part 1 and for part 2. For part 1, all we do is simply reduce this to do a power of 2. It's 2 to the winners minus 1, or the total amount of winners minus 1, because we start at 1, and then after that, every time it's doubled. Which, of course, 2 to 0 is 1, 2 to the first is 2, but because we have 1 winner, it should be 1. We have to reduce that by 1 for the power to work correctly. But that's part 1, pretty straightforward. Part 2 is a little bit more difficult, because instead of counting how many have won, whenever a card wins, you're given the following cards, and then you kind of play them out, if that makes sense. And this is actually just asking us how many cards we have at the end. Because of that, we have this reduced, but instead of powers, we have to slice this. So we start at, so let's start at card 0. Let me go back to the test input, or back to this. Because card 1 has 4 winners, we are given these next 4 cards. Oops, these next 4 cards here. And they're kind of added virtually to our cards. So what that handles is that we slice off from the 0th index to the index of the next card to go to. And then we get that and the next amount of winners cards. So in this case, the first is 4. So we get the next 4 cards. And we increment them by the number of cards we have. So because the first card's a 1, we only get the next 4 cards. But because card 2 is a winner, but we have 2 card 2s. So we have to increase the number of card 3s by 2, which is just the counts at this index. So you increment it by how many of that card you have instead of just by 1. But that makes it nice and easy then, because then we can just sum the number of cards that we have with our sum, and that's it. Part 2 was, it takes a second to think about it. It's the way they explain it is easy, but taking the way they explain it and implementing that into code is a little bit tricky, but not too bad. But that's it for day 4. Not too bad overall. Part 1 was nice and quick. Part 2 made you think a bit, but yeah. So hopefully you guys enjoyed. I'll see you guys all tomorrow for part 5. Peace out.